Right, everyone, we are now looking at the final portion of redox reactions procedure, specifically part C. So if you look at the data sheet for this, report sheet on page 172, there is a table which we need to make some modifications to. Like I already explained, we're limiting the number of metals we're going to consider reactions of with salts. So you have originally 6 metals listed here, including nickel, copper, zinc, iron, aluminum, and magnesium. We are excluding nickel, so the first one, and we're excluding aluminum. For magnesium, you're only supposed to record the results with HCl, which we looked at for part B. So in part C, they sort of incorporate the results from part B as well, because the first entry in the column here is HCl. So for HCl, this is actually part B results. And then you have salts listed here. We're not going to use nickel sulfate either, so you can cross that out. So we only have going from top to bottom in the table on page 172, we have HCl, we will have copper nitrate, we will have zinc nitrate, and the last one here is ferrous ammonium sulfate, FeNH42SO42. This is the salt that contains ferrous ion plus 2. I would also like to mention that below the table on this page it says balanced net ionic equations. What I actually would like you to do for this part, well, actually both parts B and C, I'd like you to write all equations for reactions we observe happening in either ionic form or molecular form on a separate sheet of paper, and please upload that sheet with chemical equations onto Canvas alongside your lab report. So in addition to pages 171 and 172, I would also like you to include a sheet with chemical equations. 2 things regarding chemical equations. They can be written either in ionic or molecular form. Regardless how they're written, they must be written, they must be balanced, and the state of each substance, either aqueous or solid or gas, must be specified. And also remember, any metal ion that's produced in the course of reaction here can be assumed to have a charge of +2. So majority of them start, if they're in solution, they're ions, they start at +2, and if any metal in elemental form gets transformed into an ion, that ion may be assumed as having charge of +2. So first we're going to look at copper metal. So I have copper metal here, which we're combining with 2 different salts. One is ferrous ammonium sulfate, which is a source of ferrous ion, Fe+2. And the second solution we're combining metallic copper with is zinc nitrate, which of course is a source of zinc+2 ion. So question is, will copper be able to replace iron from ferrous ammonium sulfate salt? And will copper be able to replace zinc from zinc nitrate? So I'm going to show you 2 beakers here. So this here is copper with ferrous sulfate. This here is copper with zinc nitrate. Originally, of course, copper strips look like this. And both solutions of these salts are clear and colorless. Well, not quite clear, I shouldn't say that. Ferrous ammonium sulfate is a little cloudy of a solution, but it's colorless. And zinc nitrate is clear and colorless as well. I can show you what the original solutions looked like. You can see that ferrous ammonium sulfate is somewhat cloudy, but it's colorless, and this zinc nitrate here is clear and colorless as well. So do we think there is any chemical reaction happening? I'd like to mention that all of these that I'm going to show you for this part have been sitting in these beakers for at least 20 minutes. I let them sit as long as I possibly could so you could make a determination whether or not reaction has happened. And think about also which metal is more active. Remember, only more active metal can replace less active metal from its salt. So based on our reactions of metals with HCl in part B, do we think copper is more active than iron? And do we think copper is more active than zinc? So that's the question I'd like you to answer here. Next, we're looking at zinc metal. And zinc has been combined with two salts, copper nitrate. So I took a piece of metallic zinc and I put it in a solution of copper nitrate. And the second one is a piece of zinc that had been placed in a solution of ferrous ammonium sulfate. And we're going to take a look at those two beakers next. So this here, and we're gonna try to show it to you. This is zinc metal in solution of copper nitrate. I'm going to try and use my tweezers here to remove zinc to show you. And we're going to compare this zinc with original metallic zinc that I have in this jar over here. So take a look at the surface. Oops, I'm sorry, I dropped it. So you can see what it looks like now. Oops, dropped it. Keep dropping it, I'm sorry, it's tiny. So how does this zinc here compare to the pieces of zinc in this jar? Hopefully you can see the changes that occurred on the surface of zinc. You might be able to see orangish brown, not orangish, but brown powder on the surface of zinc. It definitely got darker in color. And in this beaker from which I removed it, you can see some solid on the bottom. So question is, has there been any reaction? I think you can make a definite conclusion here. Next, we're going to take a look at zinc and ferrous ammonium sulfate. And here you can also see that in this case, zinc did not change as much. I mean, I'm talking about the metallic piece of zinc sitting on the bottom of this beaker. But take a look at some particles of solid floating around next to zinc. I hope you can see it. We can try to take this zinc out and inspect it a little closer. Look at the pieces of black powder, especially on this side of the piece. So here the reaction may be less obvious, but remember the results of our test with HCl, which metal was more active, zinc or iron? So can zinc replace iron from its salt? Hopefully you can answer that question for me as well. Lastly, we're looking at beakers containing iron. So here I put pieces of metallic iron which I cleaned with sandpaper prior to conducting this experiment. So piece of iron, metallic iron, has been combined with solution of copper nitrate, and in another beaker I have piece of metallic iron combined with zinc nitrate. So we're going to observe what happened there. And first, of course, a reminder what pieces of metallic iron looked like. These are the ones that have not been cleaned. That's why they're all gross and brown, covered with rust. So after I cleaned them, they looked very similar to zinc, sort of shiny and gray. This here is iron that was placed in a zinc nitrate solution. And this here is iron that has been placed in the copper nitrate solution. Of course, copper nitrate, because it contains copper ions, is originally blue. Zinc nitrate is colorless. Zinc ions do not have any color to them, unlike copper ions do. So do we think iron has changed any? That's the question. So can iron replace zinc from zinc nitrate, right? And the second question is, can iron replace copper from copper nitrate? Again, here to make a prediction, we can rely on results of part B. I took out this piece of iron, and what I'm hoping you'll be able to see is brownish traces of metal on its surface. This is not rust. I promised you I cleaned it really well with sandpaper before I put it in. So what could this be if it's not rust? Well, could it be copper atoms that formed on the surface of the metal? So that's something for you to think about. Which metal is more active, iron or copper? Did iron react with HCl? Did copper? So this is the hint that you can use here to make this determination. Now, unlike with copper, I'm going to take this piece of metallic iron out, so we can take a look at that one. And here what you can see is that this piece of metal is pretty much remaining gray with no traces of black or brown powder on its surface. And so again, here hopefully we can make a conclusion as to whether in this case iron can replace zinc from its salt. Again, which metal is more active, iron or zinc? You'll notice on your report sheet you will have to rank these metals in order of activity from most active to the least active. You don't have to include aluminum or nickel because we did not use those metals, but you have to include hydrogen. And the way you include hydrogen is you consider the results from part B. So these are all the videos for this lab. Hopefully these will help you fill out your report sheet. Stay safe and well, everyone.